In today's video lesson, we're going to start an introduction to organic chemistry by looking at alkane nomenclature, and this is kind of the foundation for this entire concept of organic. So alkanes are hydrocarbons that are linked together by single bonds. For example, CH4. If I draw the Lewis dot diagram for CH4, it looks like this. And we see that it's all, again, singly bonded, so it's an alkane. So to do the nomenclature for this compound, I'm going to use this little prefix chart that I wrote down on the side. I see that there's one carbon atom in this structure, so that has the prefix meth. And because this is an alkane, so it's all single bonds, it will end with ane, so CH4 is named methane. Let's look at C2H6. So if I draw the Lewis structure, I won't draw all the hydrogens this time, but it looks like this. So it's all singly bonded as an alkane. There are two carbons in its backbone. So I'm going to use the prefix for 2, which is eth. So we're going to call this structure ethane. Okay, so eth meaning two carbons and ane meaning all single bonds. We can do the same thing for C3H8. Use your prefix chart. 3 carbons has the prefix prop. All of the single bonds are shown here, so this is propane. And then C4H10, we can go on and on, but C4H10, this will represent butane. But meaning 4 and ane meaning single bonds. All right, now what I'm showing you in these initial structures, these are all called parent chains. So parent chain, what I mean by that is that it's just carbons that are attached to each other and hydrogens. So there's nothing else attached to these molecules. It's just carbons and hydrogens. We call those parent chains. Now, if we increase the complexity a little bit, we can have parent chains with substituent groups. A substituent group is essentially a group that's hanging off of the parent chain. So let's look at this structure. For example, I've got a parent chain of 6 carbons. I'm going to actually number these carbons this way. So we're going to number it backwards. And I'll explain why in a second. But there are 6 carbons in my parent chain. And what we see here is on carbon number 2, there's a substituent group. So this is not part of the main chain, but this is an extra group on one of the carbon atoms. So this is called a substituent group. And how we're going to name this structure is we name this substituent first, then we name the parent chain. So by the way, the parent chain is 6 carbons, and it's an alkane. So if we look at our prefixes chart, we know that this is a hexane. Now this substituent group is 1 carbon. When we name it, we're going to call this, we're going to actually use our prefix chart. So it's a 1 carbon, it's a meth, but we're not going to call it methane. As a substituent group, it's called methyl. So, and then if, let's say, eth was a substituent group, you would call it ethyl. So in this structure, we're going to call this 2-methyl hexane. That's the name of this compound that has a parent chain and a substituent group. So 2-methyl hexane. So why did I number these carbon atoms backwards? Let's take a look at our nomenclature rules and try some more complex examples. So here are some rules for nomenclature. Number 1, we have to determine the parent chain, which is my longest chain of continuous carbon atoms. Then we have to determine the substituent groups. So if you read number 3, we have to number the carbon atoms in the parent chain, giving the substituent groups the smallest carbon number. So if I go back to this example up here, the reason why I didn't number it like this, 1, 2, 3, 4, 5, 6, is because if I do it from left to right, then the substituent would be on carbon 5. And according to my nomenclature rules, I need to give the substituent a smaller number. So I've numbered my carbon chain from right to left, and that gives my substituent group a smaller carbon with number 2. Hopefully that makes sense. Okay, so let's look at this more complicated example. The parent chain, we have to be careful. It's not always linear. So you have to count. If you count linear, that gives you 1, 2, 3, 4, 5, 6 carbon atoms. But if I look at this, by the way, this is an abbreviated Lewis dot diagram. If I actually look at it kind of like a zigzag sort of pattern, if I actually circle these, so if I actually count it this way, these carbons, now these are continuously attached, right? This L shape, if you look at this, there's 1, 2, 3, 4, 5, 6, 7 carbon atoms. This is a longer parent chain or a longer carbon chain. So this is the parent chain in this compound, which makes this, the things that I'm going to circle, these are your substituent groups, and also this one. Okay, so now that I've identified that, let's number our carbon atoms. And again, I'm going to number it so that my substituents have the smallest number possible. So we're going to call this carbon 1, and we'll go across this way. Okay, so I see that my parent chain is 7. So if you go back to that prefix chart up here, 7 is hept. And it's, again, these are all single bonds. So it's going to end with heptane. So now we have to name the substituents, and we're going to put them in alphabetical order. So on carbon 2, I've got a methyl. So this is a 2-methyl. And then on carbon 3 and 4, I have ethyls. So 2 carbons are ethyl. So we call this, let me move this. So let's call this, and by the way, we have to put them in alphabetical order. So we're going to call this 3,4 diethyl 2-methyl heptane. This is all one word. And just in terms of formatting, we separate in organic chemistry. We use commas to separate numbers from each other, and then we use hyphens to separate numbers from letters. Okay, and I also, by the way, use the word di here because there are 2 ethyls. So if there's 2 ethyls, I would say diethyl. If there was 2 methyls, I would say dimethyl, and so on and so forth. So let's try to draw one and finish off with an example. Let's draw, which by the way, I think drawing is a little bit easier. Let's try to draw 2,3-dimethyl heptane. So heptane, if you look here, has 7 carbons. That's my parent chain. So we're going to draw that first. Okay, now let's actually number these carbon atoms. Since I'm drawing, you can number however you want. So we'll number from left to right. So we'll call this 1, 2, 3, and so on. Okay, now each carbon, by the way, remember each carbon has 4 bonds. Now that I've kind of set up the backbone and this parent chain, let's put a methyl on carbon 2 and carbon 3. Now it doesn't really matter if you put the methyl on the top or the bottom. It'll give you the same compound name. So we'll put them there. That's CH3. So what I've just drawn here, that's 2,3-dimethyl. That's what this represents. And then heptane is my parent chain. That's what this linear represents. Okay, so this is an intro to organic chem with alkane nomenclature. If you don't understand one of the questions we've covered or you have any questions, please let me know. And if this helped you, please like the video and subscribe. And it would be great if you could check out some other content on this channel. Thank you very much.